So we want to find the general solution of this differential equation. So let's have a look. Hopefully it's separable. So we've got x squared plus 1 dy dx. So that's y dash. I'm going to put the y squared plus 1 on the other side. So I've got y squared plus 1. And you see it will be separable. The trouble is I'm going to have to put that y squared plus 1 underneath. And the dx also, I'm going to keep the minus here, the x squared plus 1 and the dx is over here. There we go, so it is separable. So we've got inverse tan, so inverse tan of y, and we've got minus inverse tan of x plus a constant, let's call c. So it's a general solution because we've got the c in it, so we could make it look a little prettier by putting the inverse tans together, equals c, just like that. Now, if you're like me, you're always tempted when it's inverse trig of something to let them be a and b. So if I let this be a, in this case, give away to that temptation. Here we go, a plus b equals c, where a is inverse tan of y and b is inverse tan of x. That way, when we are looking for the, the general solution is equivalent to this. All right. So you can see my A's and B's will turn out to be nice here because we want everything on the other side and just the constant on the other side. So if we basically tan both sides, so what we're doing is we're saying I want tan of A plus B, where A and B are those things there, equals tan C. Of course, tan C will be a constant. Let's make that constant a different constant, but remember tan A, tan B is the same as tan A plus tan B on 1 minus tan A, tan B. Now that will come in handy because, so tan of A is tan of inverse tan of y. So tan of A is just y. Tan of B will be tan of inverse tan of x, so it's just going to be x. So we can get y plus x on 1 minus yx, equaling, let's say k for some constant. Tan c is some constant. Okay, so now it's in that form. Oh, d, sorry, d they wanted. So we're going to call d, where d is tan c. Okay, so once we've got that, using our trig knowledge, we now want to use the initial value problem. So we've got y0 equals 1. So when x is 0, y equals 1. So let's put that in here. So y equals 1 when x is 0. Y equals 1 when x is 0. So that's going to be 0. So you can see d is just going to be 1. So if we put that back in, we're going to have that equaling 1. So if I put everything now nice and flat, there we go. If I put all the y's on this side, anything with y in it and anything not with y on it on that side, then I can factorize by y. And you can see that y will then be 1 minus x on 1 plus x.